We're given a sequence of numbers 200, 180, 162, and 145.8 ... So when you see this ... that means it's implying that this sequence goes on to infinity. Okay? And we need to find a trend in between these terms in order to identify the common difference or common ratio. So the first trend I can see between 200 and 180 is subtracting 20, and then 180 to 162 subtracting 18. So those two values are different, so it cannot be an arithmetic sequence. Let's look for a geometric sequence here. So in order to do this, we can use the formula. Common ratio r is equal to u n plus 1 over u of n. Okay, and let's choose our u of n as our first term, which is 200. So our u n plus 1 will be our second term, which is 180. So we get 180 over 200. And this can simplify into 18 over 20. We can divide both by 2. So we get 9 over 10, which we know as 0.9. So our r is 0.9. And in our previous video, we covered the formula for a geometric sequence, which is u of n is equal to u1 times r parentheses to the power of n minus 1. So we plug in here our first term, 200, times our common ratio, 0.9, to the n minus 1. The last thing we need to do here is write a sigma notation. Our lower bound, we used 200 as our first number, which is our first term. So we're going to write n is equal to 1, our first term. And on the top, we know that the upper bound goes to infinity based on these dots in the after the sequence. So we can write our upper bound as infinity. Now we plug in our formula. 200 times 0.9 to the power of n minus 1. And this is our final answer for this question. Okay. Next we have -3, 5, 13, 21, and 29. So we see there are 5 terms here. So 1 to 5. Okay. And a trend I'm seeing from -3 to 5 is adding 8. So if we add 8 to 5, we get 13, plus 8 is 21. So it's pretty clear that this is an arithmetic sequence, but if you wanted to use the formula to check, then you could take the common difference, d, is equal to u n plus 1 minus u of n. So if you use the first term as our u of n, we get -3, and our second term would be 5. So we're going to take 5 minus -3, which becomes 5 plus 3. We get 8. So we know our common difference is 8. And the formula we use for the arithmetic sequence is u of n is equal to u1 plus n minus 1 times the common difference, d. Now if we plug in our numbers here, -3 as our first term plus n minus 1 times our common difference, 8. This becomes -3 plus 8n minus 8, which gets us -11 plus 8n. Okay, and once again, all we have to do left is write this in sigma notation. Similar to the first problem, we used our first number, which is our first term, in our substitution in our formula. So we will start this with our first term. And we know that this goes up to 1, 2, 3, 4, 5 terms. So our upper bound will be 5. Now we plug in our formula, negative 11 plus 8n, and that is our final answer.